Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome back for another week of NL Math Man Math Help Streams. Here we are on day 30. Day 30 of streams, holding it down. Holding the fort, here on this wonderful Monday. You know, it is relevant, right? It's important to talk about. Would Garfield hate Mondays if John worked from home? Right? I mean, like I've done some research and stuff on like writing and university on comic strips and stuff. So, maybe I'm one of the foremost experts in Jim Davis scholarship. I mean, probably not, right? I actually didn't. I didn't. I didn't talk about Garfield at any point. But I mean, there's got to be someone out there, right? Like who's a Jim Davis scholar in a prominent university? Hmm? Like, do we have those? We should, right? Like, obviously, pop culture needs its Davisians, right? I mean, come on. Like, there needs to be a whole ream of scholarship done to determine why indeed why indeed does Garfield hate Mondays if he's a cat, right? Like he doesn't got to go to work. Must be because John has to leave, right? You know, that's the only thing that makes sense, right? I'm not a Davisian though. I don't really know. Real Albert Einstein. Yes, good morning or afternoon or day. Good day. It's a good way of saying it. Where is this unique picture taken? Ah, yes. So this is near Loch Ness in Scotland. Um, yeah, it was spring 2014. So yeah, 6 years ago, almost 6 years ago exactly, even because the days for the breaks are a bit different in the UK than they are here. So it wasn't quite the same time as the Easter break. But yeah, pretty much 6 years ago, and this was fairly high in the Highlands, right, of Scotland. I just happened to another person happened to walk by the trail as I was going, so I asked them to take a picture of me here on this intricately carved rest bench. It's not the greatest picture of the hike that I've got, but it's one of the only ones that has me in it, right? So I thought I would stick that up. It's yeah, I stayed in a place called Drum the Dropt, I think is how you pronounce it, but it's a small little village um, on the western side of Loch Ness. And then I took the coach, like an overnight sleeper bus from London to Inverness, which is also a very nice town. Um, my backpack got left. It got stuck in Glasgow. Apparently, my backpack got off in Glasgow, and I got off in Inverness. So that's a long ways away. So I had to wait half the day or so for my backpack to get there, but I got it eventually. And I got to go out to Drum and take some hiking, north and south along the loch. It was great. That was a that was a good vacation. I thought, since I've shown some hiking pictures before on stream, thought maybe I'd go dig through the trove and find some hiking pictures from things other than just that one Green Gardens hike that I keep showing pics of. Right? Yeah, that is it's Scotland. Also, there was a yes. When I was walking on that very trail, I should get a picture of this. Actually, it was an incredible thing that I saw. There was a sign up that said "The Newfies of Loch Ness," and I just sort of did a double take. I was like, "What the frig is this? The Newfies of Loch Ness? What in the world is that?" Like, I went and read, and it said, oh, these Canadians came to Scotland during World War II. The World War One actually mentioned World War One, and I had to leave a note. They actually had a comment box where I had to leave a note and said Newfoundland was not part of Canada in World War One, which is true, right? They weren't. We wouldn't have been Canadians in 1914, right? Wouldn't have been Canadians until 1949. Anyway, but yeah, it just so happens that the place I was hiking in along Loch Ness was also one of the sites where the Newfoundland Forestry Corps had gone during World War One, which is, well, of course, a lot of people know about the Newfoundland Regiment that served in the First World War. Not so many people know that we also sent a contingent of soldiers as what we call the Forestry Corps, which went to Scotland and helped greatly with the war effort by logging and producing raw materials that were then used to create weapons and material for the army. Um, my great grandfather, actually, who I'm named after, was in the Forestry Corps. He actually lied about his age to enter World War One, along with some other people that he knew. And they found out on the boat over that he was a year too young to actually go to the front. Which, I mean, that might be the reason I'm here today. Is because of that, right? But yeah, so he was sent to the Forestry Corps then when they realized that he was too young to be in combat. He did see combat eventually. He thankfully he missed Beaumont Hamel. Actually, I found out that his first battle was, I believe, Monchy Le Preux, I believe, was the first one that he was in. I did some research actually a few years ago at the rooms when I was volunteering there, in order to try to find out some stuff about my grandfather. Cool how terrain is practically exact as here due to Newfoundland being connected to the UK and Pangea times. Oh, yeah, that's a great, yeah, that's a great point actually. Yeah, Newfoundland. Well, I mean, for one, we do have a similar climate to Scotland. Scotland's a little warmer than us, but not much. Maybe like 5 or 10 degrees on average, right, across the year. And yeah, the terrain is very similar. Newfoundland was connected to the UK. Yeah, we're part of Avalonia is this small like sort of mini continent. I guess it's a continental plate. It's not technically one of the one of what we call the continents, sort of um, politically, I guess. But it is a continent in that it's its own continental plate, and that contains part of Newfoundland and then a lot of the UK. Also, other parts of Newfoundland came from Africa, and because you can see how like Newfoundland sort of meshes in there in between, sort of part of Newfoundland kind of meshes in between Spain and North Africa when it's all in Pangea, right? But yeah, you're absolutely right about that. Yeah, I got to see a forestry corps site, a site where the Newfoundland Forestry Corps worked. That may have been where my great grandfather worked. He might have been on that exact site. We don't exactly know where he was when he went over and in the forestry corps in Scotland. But yeah, it was just I wasn't even looking for it. It was just a random piece of Newfoundland history on a hike in Scotland, which is yeah. And it mentioned how a lot of the Newfoundlanders, married Scots lasses and lassies. I don't know. Does lassies? Would that be women or would that be dogs at that point? I'm not entirely sure. My Scottish lingo is not great, but yeah, it was a really interesting random thing to see. Anyway, yeah, I could talk about maybe I'll dig into my pictures a bit and see if I can get that picture of because I took a fairly decent photo of the actual plaque there that said the Newfies of Loch Ness and then explained about the had a big diagram there of the site that showed all the like the saws and all the stuff that they had set up. Yeah, it's the interesting piece of shared history there as well for sure. For today now, I'll get into some of the math there briefly. I am going to start off with a brief distance teaching intro. I have another new student starting today who's doing, I believe, the full math program. So welcome aboard. I have covered some distance teaching intros before, so I'm not going to go over it in too much detail. And I do send out emails and things like that to let students know, you know, excuse me, let students know a bit about the expectations, but I just want to walk through the guide very briefly and what stuff goes where kind of. Then I'm going to do a review for Unit 1 test of that same course, Math 11. Geez, hiccuping. Hold on. Okay, hopefully that handled my hiccups. So I'm going to do an intro to Math 1102A, which is not an intro, well, also an intro. Boy. Anyway, it flows really well, doesn't it? Boy, his cadence is it's just so smooth and just, conversational. Um, I'm going to do a review for Unit 1 of Math 1102A. So for Evan, I believe, the new student, that'll be very useful for you as well because that'll be the first unit that you'll be expected to do. Just so happens that there is a student writing a test on it tomorrow. So you've come in at a good time to get a little bit of a primer in what you'll be doing in that unit. Then I'm going to do a bit of a review for Math 1101, or sorry, 2101A, Unit 1. And that'll be another little bit on inductive versus deductive reasoning and such. Okay, so now to skip on over then, I'm going to bring up the guide study guide and go over here to this display. Here we go. So now you'll see over on the the right the right hand side of my screen, that's the study guide that you'll have gotten sort of in your registration package. Right? And as you go down through, you'll notice over here, my cursor showing up? No, it's not. Okay. Over here, it shows you the evaluation, written notes, including all of required work, 10%. Now, the distance teaching intro, point one. Oh, zoomed in too far. There we go. Point one, notes. Notes are recommended but not required. Oh, Slayer Darth, hey, how's it going? Yeah, finished reading my finance textbooks on the brushing up on maths. Well, great. Yeah, welcome back. And yeah, maybe I'll cover some stuff today that'll be useful for you. There's some past GCSE math exam papers to ensure my math is up to scratch. Yeah, that's a great way of doing it. Yeah, past papers. Um, yeah, when I taught well, I did a lot of GCSE prep with the students that I had in the UK, and we did past papers a lot. It is a great way of seeing the kind of level that the math will be on and the sort of topics that'll be on there as well. I do recommend anyone, say, anywhere else who's trying to prep for, say, university start in the fall. Like in Newfoundland here, local university has said that they're uh, going to let students in, even though they didn't finish, like, say, the full year this past year. But there will be a math placement test, of course, because they always do that at this university. And I would strongly recommend reviewing past public exams as a great way of prepping for that. And yeah, past papers for GCSEs are all publicly available, I believe, and a very good resource for sure. We have the notes in these courses for distance teaching. These are recommended but not required, so you don't have to do them, but I do very strongly recommend doing them because you have the solutions at the end of your guide, right? So it's a great way to get feedback immediately and know if you're doing the questions correctly. Right? You don't have to submit those to me. You do, of course, have to submit the assignments. So assignments are at the end of each unit. Right? So let me just scroll down here through the page here. Right? You'll see that it works down through some notes over here. These are really good, but these are the pages that I'm talking about that you're not required to submit over distance teaching, but they're really good ways to practice and make sure that you're doing them correctly. And if you ask me any questions about these ones, I will answer them completely and in the most detail that I can, because these aren't for marks, right? Whereas ones on the assignment, I might not necessarily walk you through every last step because I still want to see if you're able to take some of the steps yourself. Right? But after you finish a unit, you'll see I'm just scrolling down through here. You'll see this part here, right? Complete term sheet number 1 attached to the end of the booklet. Assignment 1 attached to the end of the booklet. We've actually updated it a bit. They're not at the end, they're on the following page of the booklet, right? So your assignment conversion chart and formulas are here. Keep on scrolling. Term sheet, keep on scrolling. Here's your assignment, right? So this is assignment 1. After you finish All right. So after you finish an assignment, you get a review sheet to submit. Now, this review sheet is where a lot of the extra marks, it's where we make up the marks that you don't get from the notes, right? So those marks aren't part of the course anymore. But after you finish an assignment, you get a review sheet to submit. Um, So the review sheet is similar to the test questions, right? So it's a great idea to do the review sheet. You get some extra marks to help account for the fact that you're not doing the notes. And then you also get the bonus of having some really good review for your test, right? Okay, after you finish the review sheet, you can write your test on the next testing day. Actually, I should call this math distance teaching intro because this is mostly specific to math. Now, of course, all the other courses that we have also are observing testing days. Um, and like the intro email mentions, those are Tuesdays and Thursdays. It's the same, but synced up with the other campuses at Academy Canada, and we do those with a time limit in order to maintain, some rigor in our testing, right? Because we are accountable to the government, to AESL, for any credits we award. So we are taking very clear steps to maintain the integrity of our exams, and a big part of that is the time limit, right? So it might seem a little draconian, it might seem a little extreme, but it's for a purpose, and it's a very generous time limit. 3 hours is more than enough time to do one of these math tests, right? So after you finish the review sheet, you can write your test on the next testing day. Uh, for the general program, there's one test per unit, but no final exam for the general, right? So just once you write your test on that unit, that's the last time you're going to be tested on that topic until the topic comes back up, and they will. All the topics keep coming back. Um, Pretty much every topic that you see in this program, you're going to see at least 2 or 3 times, but you're going to see it in a bit more detail each time following. All right, so this is just sort of a brief breakdown of how it goes. The notes are mostly what's in the guide here, but those are not required, but they are strongly recommended. Then you have the assignments and the term sheets. Those are required, so that's like this one here. After you finish those, you get a review sheet. After you do that, then you're eligible for the test on the next available testing day, which will either be the next Tuesday or Thursday. Um, in some situations, like if you for these courses, you generally should be able to always do your test on the next testing day. If it just so happens that I'm totally swamped with work with correcting, I might not get to it. But after the first initial like big surge of work, I've gotten a pretty good handle on keeping it cycling through pretty quickly, right? So generally that won't be a problem. So that is just a brief intro there. Let me go back over to my intro screen, get rid of the stream start soon message there because it's going. So now, distance teaching intro, Math 1102A test, Unit 1 test review. Okay. Now, what questions did I want to do for that one? Page 50 in the textbook. Okay, here we go. So I have a digital copy of the textbook. Evan, or anyone else, if you want one, you can get one as well. Oh, yeah. There we go. Black out my face here. Improve the picture a little. Um, so I've got a digital copy of the textbook, which I can, show on screen here. If you want to have a digital copy of the textbook as well, you can let me know. We do hand out these ones, and for any future book, you may have to use a digital textbook because we are running out. I'm not sure if we have any more physical copies left even. And it's safer to use distance textbooks, digital ones, and it's the exact same book, right? Anyway, this is Math 1102A, Unit 1 review. And I'm going to go down through page 50 in the textbook. Okay, I'm going to do quite a few of these questions here. So question 1 asks us, which of the following has the lowest unit price? Right? Well, so how do we find the unit price? Unit price is just price divided by number of units. Now, Renetta, I know you're the one that's going to be doing this test tomorrow, I gather, if you want to, of course. Um, I haven't picked these topics because I think they're ones that you're lacking at or anything like that. I just want to do a really brief overview of like all the different things in the course. Right. So which of the following has a lowest unit price? Well, I'm going to do 250 ml divided by $1.58. Right. If I do this, I'm going to get the milliliters per dollar. Right. If I get milliliters per dollar, I'm going to want a bigger number. But this is not how we find unit price normally. We don't normally do milliliters per dollar. What we would normally do is the dollars, the amount of money per one unit, right? ML per dollar is not what we're looking for. What we're looking for is $1.58 per 250 ml. And that's going to equal a number in dollars per milliliter to tell us how much money it takes to get 1 milliliter of this stuff. So it's just $1.58 divided by 250, 0.00632 dollars per milliliter. And for my purposes, I'm totally fine with you leaving it as dollars per milliliter. I don't care if you take it and then multiply it by 100 to be dollars per 100 milliliters, right? But this is how many dollars it takes you to get 1 milliliter of whatever the heck this was. You know, sometimes in your book it would say 0.632 dollars per 100 ml. But you know, I'm fine with it being left like this. Can I ask a dumb question? No, you absolutely can't because there are no dumb questions. But you can ask a question. Yeah, yes, absolutely. Yes, go for it. Yeah, I know there's a little bit of a lag in you seeing what I'm saying on here. So yeah, whenever Slayer Darth, whenever you've got your question ready, I can answer that. I'm just gonna go through and write out a few more examples of this here. Now this last one, part D here, is just sort of why I've carried on and kept doing these ones. I know these are all fairly samey, right? But for D, it's actually in dollars per liter if I leave it alone here like that, right? So if I do dollars per liter, I'm totally able to do that, but I'm not going to be comparing apples to apples with the rest of these guys, right? Because this was dollars per milliliter, dollars per milliliter, dollars per milliliter. So if I want to have it to have to be able to compare them directly, it needs to be the same unit. So instead of 640, instead of divided by 1 liter, I can call that 6.40 per 1,000 milliliters, which is going to be 6.4 divided by 1,000, which I don't really need to do in the calculator, but I'm going to anyway. 0.0064 dollars per milliliter. And from that, then we can see now that our cheapest one is C. Okay, Slayer Darth, let's see here. When they ask you to calculate the square root of a number, and you know it's a floating point number, say the square root of 90, there's no floating point number that exactly reaches 90. You round up to the nearest answer. Now the answer is between 9 and 10. 9.5 squared is equal to 90.25. Um, yeah, I mean, I think that's the best way to do it. If they ask you to do it without a calculator, then that is exactly what you're going to be doing. That is exactly what you're going to be doing is sort of rounding it, right? To be, well, I know it's more than 9, I know it's less than 10. So if you had to do it without a calculator, then absolutely, yes, you would. Basically, yeah, 9.5 is going to be a really, really good estimate. If you're doing it with a calculator, of course, then you're just going to plug that in, right? Plug it in and get that, and then you could round it. 9.49 here, say, right? Yeah, absolutely. That is the exact way you would do that. Okay, so let me carry on here. Number two down on this page. A standard oil barrel, 42 gallons used in the United States, is a measure of crude oil and petroleum products. What is the closest equivalent in liters? Okay, so now you're going to need a conversion factor between gallons and liters. Now let me actually oh, hold on a second. I don't have it here brought up. Oh, that was a mistake. Give me just a second. Give me just a second here. 1102A and formula sheet conversion chart unit 1. Here we go. There we go. So this is the conversion chart that you're going to have on your test. And this is the same one that we've given out all throughout this unit, right? And you see now, since we have a number in gallons and we need to get the liters, we're going to have to use one of these guys. So here we go. We've got 1 gallon. We've got 1 gal. 1 gallon equals 3.785 liters. Right, so if I flick on back over then to, oh, no, that's the next thing I'm getting to. Boy, it's going to bounce around until I find it. Here we go. We got there, right? So 42 gallons, we're going to convert that to liters. But we know that 1 gallon is equal to 3.785 liters, right? So there's a few different ways that we can do this sort of multiplication here. What I'm going to do is I'm going to make sure that my units cancel so that I'm left with the number of liters afterwards, right? So I've got 42 gallons. I'm going to multiply it by sort of this conversion factor as a fraction. But I want gallons to cancel, so I need the number of gallons to be on bottom. So I know that the 1 gallon is going to be on bottom, and the 3.785 liters are going to be on top, because the goal is to get those to go away, so I'm left with liters. So all it's going to be is just 42 multiplied by 3.785, 158.97 liters. Okay, so clearly the answer there is going to be C for 2. Worked on paper that 9.4 squared is 88.36, so I guess what I would do is work out what, say, 9.45 is, try to round your answer. Yeah. You could definitely do it that way, for sure. Right? So is it asking you to do it to 2 decimal places? I mean, that's what the test would be. That would be written there in the instructions for the question, right? But yeah, that definitely sounds like a good way to answer that question. Question 3 here is one that I wanted to do because I wanted to show a little bit about reading this chart up here, right? Okay, yeah, if it hasn't specified, you could do 9.45 squared as well. I would maybe keep it to 2, just do 9.5. But hey, it's up to you. It wouldn't definitely wouldn't be wrong to try that for sure. So you have $50, we're the closest equivalent in euros. Now, so we were trying to convert to a number of euros, right? So we've got from our chart over here, we see this is US dollar in Canadian. We don't need that. Euro. So 1 Canadian dollar is about 73 euro cents, or $1.37 Canadian is about 1 euro, is what these charts are telling us, right? So reading this chart is maybe a little unintuitive because it seems like they've got two different um, conversion factors for the same thing. But all these are just opposites, right? Because if I was to do 1 over 1 divided by this number, I would end up with this number, right? Or if I did 1 divided by this number, I'd end up with that one, right? So it's just sort of a reverse of the same thing. But all it means is 1 CAD is this much euro, and over here it means 1 euro is this much CAD. It's a bit of an oddly phrased sort of table, but this is the same way that you will see it on your test, right? So what I'm going to do is I'm going to say there are 0.7, excuse me, 727323 euro per CAD, right? And once I know that it's right, I have CA down below here, Canadian dollars on top here. So now I know that I can go ahead and just multiply those guys, right? Because the point is to get CAD here and the CAD here to cancel. That will cancel with that. And then we'll be left with 50 times this decimal, and I'll plug that in here now. So 50 times 0.727323. We're going to have 36.37 euro. Oh boy. So the closest equivalent in euros then is going to be 36.40. Hey, they were tricky. They were tricky there. Look at that. They gave you A and B were pretty close, but we know that this has a 7 here, so it would round to 36.40 is closer than 36.30. So that one is answer B on the sheet. And then I'm going to go ahead and, yeah, I'll do question 4. And then, Renetta, I think that's probably a good amount of review for this unit. Yeah, I think you were sailing through this one. So I don't imagine there being much problem here with this one. But let me know if there are any ones that you need or want specific answers to. So 4A, freezing point of water is 0 Celsius. What is it in Fahrenheit? Well, we might know. We might know off the top of our heads what the freezing point of water is in Fahrenheit. But for purposes of this test, or this unit in general, you're going to be converting them, right? So let me just zoom in a little bit here so we can see this a bit larger. But we've got these two formulae over here, right? These are the ones that we're going to use. So this is the same formula, just rearranged 2 different ways. So honestly, you could use either of the formulas for either of the conversions, so long as you fill them in correctly, right? But we know that degrees in Fahrenheit is equal to 9 over 5 times degrees Celsius, and then we add a 32, right? So if now I bounce back over to the page in the book, right? The freezing point of water is 0 Celsius. What is that in F? Well, I'm going to put a 0 in here. 9 over 5 times 0 plus 32. That's going to be, of course, 0. So the Fahrenheit is going to be 32. 0 Celsius is the same as 32 Fahrenheit. Like I said, you might have known that one off the top of your head. But even if you did, on a test, you would have to write this out. I'm not going to give you the marks just for writing down 32. All right? And then 4B, boiling point of water is 212 Fahrenheit. What is it in Celsius? Well, again, I could use the exact same formula that we just used in the previous one, but since you're given an already rearranged one over here, let's just use that. It's easier. Right? So that is degrees Celsius is equal to 5 over 9 times Fahrenheit minus 32. Right, and the degrees F this time is, was it 212? Boy, yeah. Right? So degrees C is going to equal to 5 over 9 times 180. 180 divided by 9 is 20. 20 times 5 is, of course, 100, but we knew that going in, didn't we? That the boiling point of water in Celsius is 100. But again, right, you're not going to get full marks just on a test for writing down 100 degrees and going on. you would have to show out the conversion, right? But this is, yeah, this is a good rundown here because in these 4 questions we've covered pretty much everything that you're going to be doing in general on these tests, right? There could be other units, obviously, for conversion than what I'm showing here, but that is like a good breakdown of what this test is going to be like. And Evan, I don't know if you've carried on watching, or from what I said, that's also a good breakdown of the different topics that you're going to see in the math unit that you're just starting. Okay, making good time here. Flip on back over to my intro screen and this picture of myself in Scotland. Now, I do have some very nice pics from that hike where I was like walking along this relatively steep cliff, like overlooking the loch. Like, I mean, not directly above it, but a little ways away from it, but it was fairly high, and you could really see a long ways over it. It was yeah, I should look and get some of my landscape shots too. See where I can get those ones. Now I'm going to move on to Math 2101A Unit 1 test review. So this one is for Betty Ann. And I think Nick is currently waiting on doing this test as well. I know he's doing some other courses, but Nick, if you're seeing this one, this is a good one for you to watch because you do need to do this test sooner or later whenever you get back to math, and I believe you're ready to do the test because you've submitted the assignment in the unit. So yeah, perhaps I'll send you the link as well just to see, if you'd like to go over that. Going to move on back over here then. Yeah, this is a good view here. So Math 2101A Unit 1 review. This is going to be, I'm choosing page 58 in the textbook. I think this is a good page to show a lot of the different topics that we're going to be covering. I know I've done these a few times recently, but like whenever students are working on these courses, I will come up with the same questions, a few times in a row sometimes. But that's because I want it to feel a bit like it's being taught in a classroom, and so you're getting, the teacher support for all the different topics that you're working on. Also, especially this unit, like especially this one, because it's so much different than the previous ones you'll see, and to be honest, pretty different than everything that comes after it too. But it is nice to have one unit on logic, reasoning, and proofs and stuff. It is an important part of math. Well, like I mentioned, when I did high school, back in the the ancient days of like 2003, back in the pre-YouTube days where we watched our videos in Flash on Joe Cartoon and Homestar Runner, right? That's the way we liked it. Way back then, I didn't do proofs in school for whatever reason. I guess the teacher just skipped them. Anyway, 1A here. We're telling us, actually, let me zoom in so we can see it a bit better on screen there, although we are going to need that diagram as well. So Danielle made the cube structures to the left. So I'll take another look at those briefly. What would the fourth and fifth structures look like? How many cubes would Danielle need to build each of these structures? Well, here's the structures over here. So let's start getting a table, right? See what data we've got. A good way to approach anything like this. Figure 1, blocks 1, right? Figure 2, and we can see that it added 5 blocks, right? So blocks 6. Figure 3, looks like we've added another 5, 1 in every direction aside from, all the 6 faces of the cubes aside from the bottom. That's another 5, so that's going to be 11. If we wanted to figure out how to do this one, well, I mean, now we've kind of just got, this is actually going back to a different math unit, isn't it? If you want to find a pattern, well, this is just a straight line, isn't it? 1, 6, 11. What's the slope here? What's the difference? Well, the constant first order difference is 5, right? So the slope would be 5. Right? Just one of the leftover ones. Right? But what's the plus b going to be? Well, we know that when we've got 1, right? So 1 equals 5 plus b, negative 4 equals b. So our line is going to be y equals 5x minus 4. And that pans out, doesn't it? Look, if we did 5 times 1 is 5, minus 4 is 1. 5 times 2 is 10, minus 4 is 6. 5 times 3 is 15, minus 4 is 11. Right? There we go. We've just gone ahead and gotten that line based on, not on math from this unit, but based on math from other units. And, you know, in general, a problem-solving unit like this should bring in bits and pieces of other units, because it's the whole goal that we're trying to test here is, are you able to synthesize and combine these different tools that you've been given and know when to use one and when to use the other, right? So make a conjecture about the relationship between the nth structure and the number of cubes needed to build it. Well, there we go, right? Here's my conjecture. My conjecture is that the nth there's my conjecture. The nth structure will have 5n minus 4 blocks. I'm saying 5 times n, whatever the nth structure is, the 17th structure will have 5 times 17 minus 4 will be how many blocks it'll be, right? That's just all I'm saying with this sort of notation. How many cubes would be needed to build the 25th structure? Explain how you know. Easy peasy, right? We're going to do 5 times 25 minus 4, which is going to equal 125 minus 4, which is going to equal 121. There we go. So that's all there is to that one, right? We had our information here, and from this we're pretty quickly, I think, able to see that this is just the representation of a line. And then once we find the slope of our line is 5, we can then solve and plug in the other ones and then find the y-intercept. So if it was the 0th figure, would have minus 4 blocks. Now, obviously, that doesn't make any sense, right? There's no 0th figure, and how in the world is there minus 4 blocks? But it's still, we can still use the sort of math to represent the situation, right? Even though at negative numbers and zeros, it all kind of doesn't make any sense and starts to break down, this line still will represent all the shapes as they go up, right? Let's see what else we've got here. Number 2. Frank tosses a coin 5 times. Each time it comes up tails. He makes the following conjecture: the coin will come up tails on every toss. Is this conjecture reasonable? No. Um, no, because Frank is an idiot. Okay, we're not actually going to say that. That's a little bit mean. It's a little bit mean to Frank. Sorry, Frank. That could be Danny DeVito from Always Sunny in Philadelphia, right? Frank, he's not an idiot. He's the foremost genius of I don't know. My Always Sunny memes are a bit out of date, although I have seen most of that show. It's pretty amazing. Um, I could say no, because one trial doesn't affect the others. I could say that, right? So he tosses a coin 5 times. Um, he gets heads. No, he gets tails 5 times in a row. That does not mean that it's a biased coin, right? Because one trial doesn't affect the next. Or I could say no, because he hasn't done enough trials to tell if coin is weighted, right? Now, if say if Frank tossed the coin 500 times and every time it came back tails, well, we would maybe start to expect then that this is an unfair coin, that this is actually weighted, right? I mean, you could flip something 500 times in a row and um, have it come back tails every single time. However, that's going to be 5 to the 5.5 to the 500, so zero. Effectively a 0% chance. According to the calculator, that chance rounds to 0, 0.5 to the power of 500. Um, it's not technically zero, but it's so small that that's the calculator's not even registering it. It's a very small chance, but it's possible. But in 5 flips, if those all come back tails, well, that's not really all that big a deal, right? Because zero point 0.5 to the 5, I mean, you got a 3% chance of that happening, is what this is telling us, right? 3% is not huge, but it's not nothing, right? 3% is, it's 3 times out of 100 that happens. That's about like one in every 33. So if 33 people flip the coin 5 times, one of those people is likely to get five heads or 5 tails in a row, right? So it's not all that unlikely. But 5 is just not enough trials, right? If he did 15, maybe. If he did 50, hey, if he did 50 trials and they all came back tails, then we could say, right? So again, this is stuff from another course, basically, right? This is probability stuff. And we haven't done a ton of probability in this unit, but it just kind of makes sense, right? That if someone flips a coin 5 times and those are all tails, doesn't mean anything weird about the coin necessarily. All right. Colby claims that the perimeter of a pentagon with a natural number dimensions will always be an odd number. Perimeter of a pentagon with natural number dimensions. Now, natural numbers are whole numbers, right? Because, for example, like in nature, what it means is a natural number is something that you would see in nature. You're not going to see like 1.5 of something. You might, I guess. It could be an animal bit an orange in half, and you would see 1.5 oranges. But generally, natural numbers are whole numbers. Also, they're not just whole numbers. They're not just integers. They are whole numbers that are 1 and up, right? Because 0 is not a natural number because you don't naturally see 0 of anything, right? Because at any point you're kind of seeing 0 of everything. Everything other than what's directly in front of you. There's 0 of all the rest of it. So 0 doesn't count as a natural number. And anyway, we wouldn't have a pentagon that was each side was length 0 because that wouldn't be a pentagon, right? That would be nothing. Now imagine that these were a little more accurate, a little more accurate to be a regular pentagon. But just say every side length is 2, right? 5 times 2 equals 10, right? Search for a counterexample. So all you had to do for a counterexample, like I said a whole bunch of times, right? Counterexample is fairly straightforward because all you got to do is show one time that the solution, that the conjecture is false. And here, obviously, like if they're all 2s, well, then the conjecture is false. If they're all 4s, if they're all 6s, 8s, 10s, if they're all even numbers, of course, then once you add 5 even numbers together, you're going to get an even number, right? So, like, fairly straightforward stuff. Number 4 here now. 4 is one of the ones that I wanted to get onto. Prove that the product of 2 consecutive odd integers is always odd. Ah, great. Good. Now I get to show a little bit about the proof stuff. And Betty Ann, I got to say, on your review sheet, which I went through very quickly today, didn't give you a mark on it yet because I haven't quite finished everything. But you did really, really well with the proofs, so I don't think there's any real problem with that. I am going to go, and actually, I'm going to do a few questions off of that as well before I'm done on stream today. But number 4 here is a really good question because it asks for the product of 2 consecutive odd numbers, and it asks us to prove, right? So here what I'm going to do is write out 2 consecutive odd numbers. So I know that 2n is an even number. It's the way we always make it even. So 2n plus 1 is an odd number. Then the next odd number after 2n plus 1 is actually going to be 2n plus 3, right? So it's important for us to know that this is how we would represent this. 2n plus 1 is how we guarantee something is odd, because 2n guarantees it's even, adding 1 then guarantees it's odd. Then adding another 2 on top of that gets us to the next odd integer in order. So 2n plus 1 times 2n plus 3. And now we're showing that the product of these is always odd. So I'm going to go through and multiply these guys. We're going to FOIL these. 2n squared plus 6n plus 2n, right, plus 3, which is going to be 4n squared plus 8n plus 3, right? And because of this plus 3, you know that. Okay, since our final step cannot be evenly divided by 2, therefore must be an odd number. Right? That's all there is to that. And that is now a proof. We have proved that one. Do question 5 here on this page, and then I'll go do a few quick questions off the review sheet. So let's see. Prove that the following number trick always results in 10. So we're proving, right? So proving means we don't need to do any sort of examples in general. We can just start off right away with the algebra. So here's n. Here's our natural number. Double it. Okay. So that's 2n. Add 20. All right. 2n plus 20. Good. Divide by 2. Okay. N plus 10. Remember to divide both terms by 2. Subtract the original number. N plus 10 minus n is just going to be 10. There we go. That's all we have to do. That is now a proof that this number trick always results in 10. Right? So this topic can seem a little daunting at first sometimes, but I think once you get into it, that actually it's actually pretty quick, right? It just sort of makes logical sense, and the algebra that we're doing is not super hard. So let me now go over and spot where I put that review sheet. Here it is. Okay. So I want to do a few questions off of this one. So I'm going to do 3D here. Let me go over to this display. Haven't used this one yet today. Oh, I'm a poet and don't know it. You got a brain and don't show it, my parents would say, and then they would laugh. Very sophisticated humor. Yeah, obviously in my family, of course. So now, this is again Math 2101A Unit 1, and this is review sheet, and this is going to be number 3D. Okay, 3D tells us the sum of 3 integers is greater than each integer. So determine whether the statement is true or false is what we're doing. If false, provide a counterexample. So this one here now is providing a counterexample. So I don't need to be trying to prove in general. All I need to do is create a counterexample that shows that this is not always the case. So the sum of 3 integers is greater than each integer. Well, like if I did 1 plus 2 plus 3, say, the sum there would be 6. So that would be greater than each integer, right? Or, 2 plus 10 plus 100 is going to be 112. And yeah, of course that's bigger than each integer, right? But how's about I did negative 2 plus negative 1 plus 0? That's going to be negative 3. Now all of a sudden, negative 3 negative 3 is less than I'll call them the input integers. Since negative 3 is less than the input integers, we know the conjecture is false. All right, that's all you got to do for that one, is just show that there is a situation that proves the conjecture wrong, right? And in this case, it all relies on the fact that they said integer. If they said the sum of 3 natural numbers is greater than each natural number, yes, that would be. But here it's telling us to use integers, and negatives are integers. Now I want to do question 4. I'm going to do both parts of question 4 here. So 4a tells us to prove each statement using deductive reasoning. The sum of any three consecutive even numbers is divisible by 3. Now that's quite a question. That's a good one. I'm going to use my red pen for this one. So 4a. The sum of any three consecutive even numbers is divisible by 3. Consecutive even numbers. Well, how could we write 3 consecutive even numbers? We know 2n, or 2x, or 2 whatever, is an even number. And what's the even number that follows 2n? Well, it's going to be 2n plus 2, right? Because 2n plus 1 then obviously gets us to an odd one. We want to skip that one. We want to get consecutive even. So 2n plus 2, and you can probably guess the next one is going to be 2n plus 4, right? You could do it in other ways. You could do minus as well. That's fine. Like consecutive works in either direction. It's all right. Right? But this is just what I'm going to go with for my choice here of 3 consecutive even numbers. So now I'm just going to show that it's divisible by 3. I'm going to go ahead and add these guys. That's going to equal 6n plus 6, which is going to be the same as 3 outside of 2n plus 2, right? Um, it's not really phrased as asking you to prove if it's correct or not, but you can phrase it like that in your answer. You just did, right? Since our result is divisible by 3, the statement is correct, right? We could also have factored out 6 here. Obviously, this is 6 outside of n plus 1, so this is not simplified fully. I just wanted to show with the 3 outside, just to make it very clear that we can indeed divide this bit by 3. Okay, so let's look at 4b. 4b is a bit of a weird one. Now, this one I really want to show this one on stream, Betty Ann, because I got to say this one's a little bit weirder than some of the other ones. Yeah, it's gotten quite small up there in the corner, hey. But what it's telling us for 4b is that basically we have a 3-digit number divisible by 5, when the last digit in the number is divisible by 5. Now, normally we don't really have a way in our algebra to represent the digits of a number, but we kind of do when we think about it. It's a little bit abstract and a bit outside the box of what you might have thought at the start, but there is a way to do it, right? Because say we had a number that was a, b, and then 5, right? This is not how we would normally write it, though. So I don't like writing this part down. The answer key does. It writes it out like this. But I don't really like writing this, because what this would mean normally is a times b times 5, which is not what we want to be doing here, right? That's not the way we're representing it. What we actually have is 100 times a, right? So then whatever digit a is, 100 times it makes the first digit, right? Plus 10 times b, and then plus 5, right? So this is how you have to write out this sort of thing. A 3-digit number. So this is the first digit, A, and it's in the hundreds place, right? Which is why we times it by 100. B is in the tens place, which is why we times it by 10. 5 is in the ones place. It's times by 1, right? But we don't bother to write that out. So now we have this, and we're trying to prove that it's divisible by 5 when the last digit in the number is divisible by 5. Well, all we have to do now is prove that this over here is divisible by 5, and of course it is, because this equals 5 outside of 20a plus 2b plus 1, right? So we can say since 100a plus 10b plus 5 is always the conjecture is correct. Now, one reason like I said, the reason I really wanted to show this one on stream is because it's quite a bit different than a lot of the stuff that you would have seen so far. Just representing a number in this format is maybe a little bit unintuitive at first, but I think once you realize this is what they're looking for, it starts to make a bit more sense. And then I wanted to do question 6b to end off today. Yeah, 6b is a good one. So this one I can even zoom in on pretty well. So let's zoom on in. So it's asking us basically what types of errors were included in this deduction. Well, what type of error indeed? Let's find out. Oh no, I need to zoom out again. There we go. That's as big as we'll get it, but it's plenty legible. Plenty legible there. So this is 6 and B. So 5 equals 6. Well, there you go. There you go, right from the start. Right from the start, that one doesn't make any sense. But okay, they've got this one written out a little bit strangely. 5 equals 6 is sort of the thing that they're trying to prove, right? It's not what it's starting off as. What it starts off as is A plus B equals C. Okay. So honestly, they kind of shouldn't have had this part here because obviously this is a mistake. And if their proof relies on the fact that 5 equals 6, it obviously doesn't work. But we don't need to concern us with that part here because this is kind of like the title. Strangely enough, we start in on this point, right? So A plus B equals C. That's fine, right? They were saying 6A minus 5A. Right, okay. Yeah, because A can be written as 6A minus 5A, right? 6A minus 5A is the same as A. That's right. Just like B is the same as 6B minus 5B, because if you simplify that out, you get 1A here, you get 1B here, right? And the same over here, 6C minus 5C. So we're good so far, right? So then we can, just by moving these guys around a bit, we can call this left side uh, 6A plus 6b minus 6c equals 5a plus 5b minus 5c. Right? Does this work out? Well, let's see. We've got a 6a that stays here. The 5a moves over here and becomes positive. Good. 6b stays here. The 5b moves over here and becomes positive. Then this 6c moves over here and becomes negative. It's also good. All right. So everything checks out so far. Then we can easily call this 6 outside of a plus b minus c equals 5 outside of A plus B minus C. That's also true. And then in the last step, they divide both sides by, I'm just going to write this step out, 6A plus B minus C, divide by A plus B minus C, equals 5A plus B minus C, divide by A plus B minus C, and that gives us 6 equals 5. Right? Now, of course, logically, on the paper, that does seem to make sense, doesn't it? Right? But remember what our premise was. Remember what our premise was. A plus B equals C. Right? Since A plus B equals C, A plus B minus C equals 0. Right? And you can't divide by 0. So here, like I said, a lot of the time when there's a proof that looks at a glance to be logically sound, what it breaks down to quite frequently is that at some point they divide it by 0. And as soon as you divide by 0, well, you can prove anything equals anything else, right? Because 6 times 0 equals 5 times 0, or any number times 0 equals 0. So as soon as you can divide by 0, you can start claiming that everything is this the answer? Do you have to say it is correct or not? No. So what we're doing here for this question, the Kevin, is we're pointing out where the mistake was made. So here, the correct answer for this question would be sort of this indication here. You can't divide by 0. I'm pointing out what step it's in, right? So to get full marks for this question on the review sheet or test or whatever, what I would want you to do is sort of circle this step here and then mention that in order to get to the next one, they had to divide by 0, which they couldn't do. Right? So this is now the way that we know that that question is incorrect. Okay, I think that was a good look down through the different subjects that I wanted to cover today. If anyone has anything to mention, anything they want me to get to, you can definitely drop something in chat there. But yeah, for the questions that my students had to do for the tests tomorrow or for the intro to the program, I think I've covered all that fairly well there today. Back over to my intro page there so we can take a look at myself 6 years ago again. That was a really great hike. I do remember that one very fondly. I actually on the other end when I got further away from the lock going north, I found this little weird little schoolhouse just out in the woods. Apparently, it was a place for like primary and elementary school students to go to have sort of lessons out in out on the land a bit. What area is this in? Yeah, this picture is in Scotland. This is just northwest of Loch Ness. And I stayed in Drum the Drocht and hiked north and south around the loch. Yeah, it was that was a very good vacation. Like I said, almost exactly 6 years ago. And I'm gonna work to find those things I was talking to Albert Einstein about at the beginning. This Albert Einstein being a person in my chat, not actually the ghost of Albert Einstein. Although they may be the same person. The jury's still out on that one. Yeah, it was quite the hike, and yeah, I should really go and see if I can find more stuff from that. It was really surreal to see that like little blurb about Newfoundlanders in World War I there on this hike randomly, which might have been a place that my great grandfather, my namesake great grandfather, um, went to when he went overseas for World War I. Anyway, thanks for being with me here today. Thanks for hanging out, dropping questions in chat. I hope that what I've covered today has been useful for you. Right, and yeah, if anyone from the school, anyone from my campus, or any of the other ones have any questions for me, you can definitely email me those. Right, or if anyone in Twitch chat has any math questions, I'm more than happy to get to them. Of course, it's always good to have some interaction, and definitely happy to answer questions as best I can on the fly. All right. Thanks for being here. I hope you have a great rest of your day. Stay safe, and yeah, I'll see you again tomorrow.